our speaker today, Hai Jun, is an assistant professor in cognitive science, directs the creativity lab, really has done a lot of creative research, thinking about systems that adopt AI, but also, really applied into making people more creative. And I think that that's a fair enough introduction. Hai Jun, welcome.
All right, thanks everyone for coming to my talk. So we're going to talk about AI for creativity. So there's no doubt AI is changing our world, right, at a scale that we cannot imagine, right? Today we are seeing large generative models that can, generate, articles, respond to your questions, but also solve hard scientific problems like, predicting the structure of a protein, right? And it's also rumored that, there will be more powerful models that are coming, right, that has thousands more parameters than existing models. And they will be far more powerful than existing ones. So I want to sort of think about what the interaction will be when we're working or living with these kind of AI systems. And I want to draw an example from everyday life. Have you ever run into this situation? Like you're trying to help someone out on a task, right? Maybe it's a task on their computer, maybe it's a task or procedure in the kitchen or in the garage, right? You will sort of stand there, tell them, hey, this is how you should do it. But at the end, you give up describing what you are having in your mind. You get into the action, you finish it for them, right? Raise your hand if that ever come to you, right? If you ever run into that situation, now here's my question. You gave up, helping that person or, telling them what to do for them. Is it because they are not intelligent enough? Probably not, right? They can be smarter than you. And if we apply the sort of methodology we're using for AI models today, does it solve the problem if the other person has 1,000 times more neurons in their brain, right? Probably not. I mean, if they have 1,000 times more neurons, they probably won't have the problem, at the first place. But my point is, the reason that we gave up describing what we want them to do is not because they are not smart enough. It's because we are having trouble describing what we want them to do, right? We are having trouble articulating our thoughts. So I don't think the problem of, this kind of problem will go away when we have more powerful AI models, right? And I think it's a really fundamental human problem. How do we express our thoughts or intent to the world, right? And when it comes with, or comes to interacting with AI systems or computing systems, is really about how do we design interfaces so that we can communicate our knowledge and intent to the computing systems. And that is the core question in the field of HCI or human computer interaction, right? Today we interact with computers in various different forms. And no matter what the form is, right, the essence of all interaction with computer system is try to communicate your intention to them so that they can do the task for you, right? And the evolution of HCI is really the process that you can gradually, express more higher level intent, right? At the beginning of a computing system, when you are trying to tell a computer what to do, you literally have to, plug or unplug wires, right? Turn on switches. If you have an equation in your mind, you have to, transform that into all those switches and, wires to get your intention across. Later, we have programming language, which is a little bit higher level, right? You can tell the computer, how should we manipulate certain variables in what kind of logic, right? And later, we have graphical user interface. Graphical user interface is basically a packaged up program, right? You have a function you packaged up, you turn that into a graphical, button that you can click, right? And, you manipulate those graphical elements, you activate those functionalities to express your intent. And that is the foundation for even some of the emerging technologies like VR and AR or, the iPad we use today. Now AI is coming, right? Everyone is asking, what should we do with AI? And before we talk about that, I also want to sort of use an example to sort of illustrate how we interact with AI models today, right? Imagine you are a graphic designer, okay? And you heard this powerful model called DALL-E 2. It takes like a natural language expression and generate an image, right? So you're like, I want to give it a shot. So you open DALL-E 2, you put in a query, like a puppy running on water in the style of Starry Night, And this is what, responded, which is pretty impressive, right? There is a dog or the puppy, right? There is a starry night as a background. And, this is just amazing, like how it can generate results like this. But it got a few things wrong, right? First, the dog is not running. Dogs don't run that way. I'm a, dog dad for we have 2 dogs, so I know they don't run this way. And the Starry Night, like it's not really the style in Van Gogh, right? The color is sort of similar, but it doesn't have the strokes, right? But still, it's pretty impressive. So, as a graphic designer, I'm gonna try to use this to actually do a graphic design, right? Maybe I would, produce something like an Easter gift card, right? That's what I have in mind, something similar to that. And I want to see whether I can use DALL-E 2 to generate a design like that. So I give it a query, like a gift card with Easter egg design. It's pretty good, right? Looks like a gift card. There's 1 egg on it. And I want to have multiple Easter eggs on top, on this card. So I said a gift card with 3 Easter eggs on it. So, you see these are the results. 2 of them have 4 eggs in it. And the first one looks like 3 gift cards, each of which has 1 egg on it. So my thinking was maybe gift card is confusing the model, right? Maybe I should just generate the eggs and then put the design on top of a background, just gift card background. So I switched my query. So now I have 3 Easter eggs in floral style. They are in floral style, pretty good, right? Okay, so next I want to change the layout a little bit. I want to, put 1 Easter egg on top and 2 at the bottom. So the first one got it right. The last one, no, the opposite, right? The middle 2 is still like the horizontal layout. But, I'm sort of convinced by the first one, so I'm gonna keep going. And I realized the first design, the gaps is, there's no gap between the eggs, right? So I want to make, some gaps so that it's breathable. So I don't know how to describe it, right? So the best query I came up with is with reasonable gaps in between. And you see the last one has reasonable gaps, right? But then one thing I realized is a very serious problem is all these eggs or the design get cropped out on the edge, right? So I'm like, give me 3 complete Easter eggs in the floral style. So, you see where I'm going, right? I'm trying to improve this design a little bit. One step after another. And then I realized the first egg, the eggs are not the same size. So I'm like 3 complete Easter eggs of the same size. All right, now they are the same size, but the layout, still not behaving the way I want. So I'm just keep trying, right? Keep trying more and more. So I'm gonna spare you with all the 40 iterations I did. This is the final query that I used. 3 complete Easter eggs of the same size, 1 at the top and 2 at the bottom, with reasonable gaps in between. For the 2 at the bottom, the left one tilts to the left, the right one tilts to the right. The top one has a floral pattern, and the bottom 2 have dotted pattern. And this is what I got. So the first one has 6 eggs in it. The second one, it doesn't have the layout as specified, and the fourth one as well. And the third one has a weird pattern, right? I'm not gonna use any of these for my graphic design. So many of these eggs are cropped and none of them is tilted, right? I'm pretty confused as well, how to interact with this model. So let's reflect on this process a little bit, right? I get started with a blank canvas. I give it a query, which is, gift card with, Easter egg design. It's somewhere, right? It got me somewhere. It's good starting design. But as I add more requirement, I didn't make significant progress towards my final design. And actually, I got lost, right, in this process. And I went somewhere else, but not the goal I have in my mind. So I think there are 2 problems in this process. First one is natural language is not well suited for describing some design intentions. For example, the gaps, I really don't know how to specify that. It could be very easily done by, using a GUI graphical user interface if I can manipulate the eggs, right? If I can tilt them a little bit. And second of all is the AI model is really confusing. It's really hard to control. And I have no confidence or idea of how it actually gonna interpret my natural language expression. So every single prompt is kind of gamble, right? Every single step, I actually don't know whether the design will be improved or actually got worse. So in our research, we do see the potential of leveraging natural language and AI to facilitate people express higher level design intentions and also get rid of all the repetitive manual operations. But how can we design interfaces with AI so that we don't run into problems like this? So in my lab, we ask questions like, what are the scenarios that natural language is well suited for expressing your design intention? And also, how should we design human AI systems so that they are more understandable and controllable? So today I'm going to show you guys a few work. We sort of explored these problems in different domains, like generating animation or presentation, or sort of like authoring data reports, and also applied it to podcasts and sports videos. So let's get into this and see the approach we take. And I want to sort of start with cross data, because this is one of the projects I really liked.
Can I ask a question?
Sure.
So if you started off with this example with human and
Yeah.
I was sort of thinking from Dolly's
Mm-hmm.
perspective, and you sort of turn it around, and Dolly was sort of asking you for help.
Right.
You're giving descriptions, and then it just goes ahead and does.
Yeah.
What it thinks you intend.
Yeah.
But it seems like you're talking about it from this perspective of the communication too, but not the other direction.
Right. Yeah, I think, like that's one thing that I would want feedback, right? Like when Dali is confused, like I don't know where it got confused, right? It's not an explicit, hey, I need help understanding this part. And later in my talk, I will sort of describe a system where you can more tightly work with AI to fix problems even AI have. So yeah, let's start with cross data first. I'm sure all of you encounter data documents in your life. If you're a professor or a student, you probably have written a data report reporting the results of your, study or experiments, right? Or you probably have read a financial report that, describe the economy situation of the country or of the world. So the data reports actually play a central role in communicating data insights and informed decision-making. So here's a data report from about COVID-19 from World Health Organization. So it described, the globe's COVID situation. And you don't need to read into it, but this report, right, and many other data reports, they usually contain a lot of numbers, right, because they are trying to, inform you of the data facts or insights driven by data, right? So here, all the highlighted phrases or sentences are, language that actually describe data, right? What is the data or what is the insight? But producing this kind of report is actually really tedious. Like, I don't know about you, though, when I write a report, before I do that, I actually need to analyze the data, right? Like you analyze the data in a spreadsheet application, or maybe some other, Tableau or Excel, or maybe you write program to analyze that. Now, once you play with the data, you know what you want to report, then you start writing about it, right? And when you're writing your report, you often need to just get the data from your analysis environment and put into the sentence, right? And that is actually a pretty tedious process because you need to switch to a different application. You need to copy over the number, right? And if your report reports thousands of data, right, a very long report, you need to do that thousands of times, right? And the worst case is, let's say you're writing, write 3 pages into it. You're like, hey, this narrative doesn't really work out. I'm gonna try a different narrative, right? And for that, you probably need to perform new data analysis. So your data is changing, right? But your document is not changing. So you have to go through the document, right? See all the places you report data and make sure, the data is, reported correctly, right? So that is a pretty tedious process. When we look into that, we find that, when you're writing or reporting a data, the language you use to report the data is very explicit. And our insight is that these data are often embedded in this really descriptive natural language expressions so that you can try to understand the language and tell the system, how to infer and extract the data automatically and automatically put into the right place of the document and maintain that data. Whenever things updated, the data is always up to date. So let me give you a toy example, okay? So this is a table that you need to write a report, and you'll report this one sentence. The user was max score in 2015. Who is the user? Do you guys know? Amy, right? And the way you do it in your mind is, I need to report the user, and I need to look at the score. I need to look at, score in 2015, right? And then there's a maximum operation you need to perform. And what we can do is we can tell the computer how to do that, right? So we build a system called cross data. Cross data basically can analyze all these words, match those words with the table, right? 2015 score and the user, and also knows the data operation, like, the maximum operation. And it combines all these, into a query by leveraging natural language processing. And with this query, you can perform that on the data set, right? And then you got Amy. And once you got Amy, you can, insert that into your document. But we also preserve this query so that whenever, your data changes, right? Let's say you have more data coming, you can perform the query again to update the data. Or if you say the user with the minimum score, the query will get updated, and then we will retrieve the user with minimum score. So that's sort of the technique we used. And let's take a look at how we actually use this for writing an actual data report. So this is the COVID situation report. I'm going to describe this table, right, which describe the cases at different regions of the world. So I'm going to start the maybe new cases. So as I'm writing, the system is asking, hey, are you trying to report new cases or new death? Because I detect you write a new, right? So I can accept the system's recommendation, say, I want to write about the new cases. So I can accept it. And that phrase is connected with the column, okay? And then I want to say, report by Europe, automatically that data is retrieved from the table and, inserted into the sentence. And okay, I'm gonna keep write. The next thing that I want to write is maybe the total new cases, right? So I write the total new cases, reported by maybe the world or in this week. So here the system knows I want to report a total, right? There is a sum operation. So it performed the sum operation for me, gave me the value, right? But it also knows that you may want to add a new total row, right, into our table. So it gives me that recommendation. And I can accept that recommendation. I don't need to update my table manually. And that table, is updated. So I'm going to keep writing, right? So the next thing I want to write maybe is I want to report the ratio of Europe, compared to other regions. So I write, the number of new cases reported by maybe Europe is a ratio to what? Like at this point, the system doesn't know ratio to what, right? So I'm going to place a placeholder here, the ratio of the total. Okay, so I have all the information. So the ratio is, calculated, and I insert a new column, right? So everything here in terms of retrieving the data or, modifying the table is done automatically by the system. So I can do other data operations too. Maybe I want to report the highest, number reported by what region, right? So the highest number of new cases is reported by, here the system recommend, okay, Southeast Asia, right? So I don't need to adjust the table, sort it and find it. It's automatically sorted. So now, like, I know that Southeast Asia report the highest number. I'm like, maybe I should change the reporting a little bit. Maybe I should report, not Europe at the beginning, report Southeast Asia. So how should I do that? Well, like you notice that all these words are connected with the underlying table, right? So I can click on this word, say, give me other values. I'm going to select Southeast Asia, and everything is updated accordingly. You see the numbers and ratios are updated. So, I don't need to do all the manual operations. So next, I realized, hey, maybe I got to notify that, Southeast Asia data is incorrect, right? Maybe it's not 1.5 million, it's 1 million. So I need to update that data. And when I update that data, everything in the report is also automatically updated. One thing that, when you write data report is that you don't always just have, your text and table. Sometimes you will have, visualizations, right? Maybe you have a chart. So here, I'm probably trying to write, Southeast Asia's maybe new cases increased or decreased in certain, time frame, right? So as I'm writing, the system is also building connections between my text and the chart, so that whenever I increase, play with the chart, the time period in the sentence is also, connected with my interaction. So one thing that is really powerful of this system is everything you write becomes a query, right? Underlying, embedded in these sentences are queries, and you can actually reuse them. So I can copy paste this paragraph. If I want to report another region, I can reuse all these queries, and I just need to, change different regions. So I have a new paragraph about a new region, right? So one thing that this is the best part, because what you're writing is not a static article, it's an interactive article. right? It's an interactive document that you can play with. As an author, I can play with this, interface to understand, what are the different ways of reporting, or what are the narratives. I can, do a lot of exploration with this interface. As a reader, you can also play with these when it's published, right? So that you are not just reading what is being presented by the author. You have the flexibility to go into the data and see what's the data insights. So now seeing this and knowing that ChatGPT is so powerful, you may have the question, what if there's a data GPT that will just automatically generate that, right? And I think that's a pretty valid question, right? All these large generative models, they just spit out the word. They don't really know the connections. Well, I think what is really valuable here is the connection that we can build with a not very smart AI, actually, right? By building this connection between the text and the data, we can let the author and the reader play with it. And imagine there is a data GPT, it gave me the article. These connections will help the author identify or verify whether data GPT is reporting the right data in the table, right? So that is still valuable. But the way this whole system works is really that it identifies manual and repetitive work in your workflow, and basically remove that so that you can focus on more important stuff, right? So this is a pretty neat project. And I think the success is we really identified a good domain, right? The user's intention is fully sort of specified in the language. And, all you need to do is just write and accept the system's recommendation. And to be honest, this is sort of not the interaction with AI I was looking for, because in a sense, it's very similar to DAI, right? You write your text, and then you just anxiously anticipate or wait the system give you the response, right? Sometimes it's correct, sometimes it's wrong, right? It's just really this, no really real interaction with the AI. So the question that I want to explore, or the research problem I want to explore, is can we define or tell the AI how the AI should interpret my data? And what if the AI make errors? Can I get into the system, tell the AI, hey, here's how you should interpret my intentions? And with that, I want to introduce you another problem, which is, you are trying to make a video, okay? Now, this time you are a photographer and you want to make a tutorial video about, basic concepts of photography. And you want to make your presentation for it. At the beginning, you want to say, today I will talk about 3 key elements of photography: subject, lighting, and composition, and I will begin with subject, right? So that's your opening sentences. And, because you're making a video, so you may want some visuals to go along with it, right? So your visual can be pretty simple, maybe 3 images on the slide, right? Each one represents subject, lighting, and composition, and they may show up one by one when you are mentioning those words, right? And when you say, let's begin with, there is a zoom in animation, maybe showing that I'm diving into this topic. And to do that, it's actually pretty tedious, right? It's a very simple effect. To do that, you need to go to Google Image, find all these images, right? Borrow them into your editing environment, crop them, resize them, align them, add up here animation, and then add all the zoom in animation. Everything is so manual, right? It would be nice AI can help out a little bit, right? But the reason that we are willing, right, to spend so much time, maybe 20 minutes even, for this simple effect is it's actually pretty useful, right? Because these animations or content align with what I want to say in my, converse or in my sentences. And that alignment or that congruence between what I say and what you see, can create engagement and facilitate comprehension. And that's the principle of congruence. But this also really presents an opportunity that we can understand the structure, right, or the content in the sentence, and use that to generate, visual content. So instead of throwing this sentence into deep neural network and who knows what gets spit out, right? We decided to take a different approach. We want to look into what are the linguistic structures that are in this sentence, right? And it's actually pretty complex. There are multiple structures in it. There are, syntactic structures, which basically describe the grammar among the words, right? And there is also semantic structure. For example, when I say, let's begin with the subject, there's an action I'm taking, which is begin, right? I'm initiating the action, and the action is operating on the subject. So I can, extract that relationship with NLP. And there's also co-reference structure, which basically says, hey, you see two subject, right? In this two sentences, they are referring to the same thing. So now with those structures, let's take a look how I can sort of tell the AI, how to make my slides. So this is the cross power environment. And at the bottom is the script you have already written for your video, right? And you want to sort of tell the AI how to generate this video. So here, whenever you hover your mouse on the text, you can sort of explore the linguistic structure the system understand, okay? So let's say I want to add the basic structure, subject, lighting, and composition. I want to add those first. So I can hover on this structure, I can click on it, and immediately have this visual template, with image show up one by one. But immediately you see there's an error, right? Instead of showing 3 images about subject, lighting, and composition, it has 4. And that is because NLP does make errors like that, right? So what I can do with it is I can just tell the system, hey, drop this out from your interpretation and only use the rest 3, and the visual is updated accordingly. And if you look into these images, the images are also pretty random, right? These images are images returned by Google Image when I use subject, lighting, and composition each as a keyword. Okay? And this keyword is they're very general. Like for example, subject, it returns an image about linguistic subject, right? What I want is a photography subject. So what I can do is I can drag and drop the photography word in the transcript, drop it onto the visual structure, added that as a keyword to constrain my search, right? So here I'm seeing images returned by Google Image. They're pretty relevant to photography, and I can manipulate them, adjust their size. Everything is coordinated among the 3 images. So next, I may want to, begin with animation, right? I want to begin with a subject. So I want to maybe have a zoom in animation on the subject image. So I click on the begin with, structure, but that animation is not what you were expecting, right? You were expecting the subject image to zoom in. And why does the system make an error like that? Because the system, in this particular case, didn't detect the co-reference between the 2 subjects. And I can fix that error. I can tell the system that, hey, zoom in onto this image, right? There's a co-reference relationship here. So what I can do is I can get into the system, right? Say, hey, these 2 subjects, they are the same. I can make a connection among them, and then the begin with structure is applied to the right image. So, at this point, I kind of want to explore different visual effects, right? Maybe I want to zoom in the first image, but at the same time, zoom out the other 2 images. And for that to happen, the begin with need to know it needs to operate on the 3 elements, subject, lighting, and composition. To do that, I can just, erase this link here and say, use the previous structure as input for the begin with structure, right? And now if I look at the effects, the begin with is applied, animation is applied here. So you may wonder, how does the system work, right? Well, there's no magic. Magic doesn't exist. The reason that it works is there's this grammar in between that governs how natural language should be interpreted, as graphical representation. So here, when I connect the previous structure with the next begin with structure, it tells the begin with, grammar that, hey, use this as input. And the begin with semantic defines that there's a selection operation. So it is select the subject out from the list and split that into 2 groups, right? Subject and the rest. And then for the 2 groups, it applies to, these different images, the different effects are applied to different images. And then, these effects are applied and the animations are generated. So here's another example. Imagine you want to talk about, in these 2 sentences, you can achieve this with lighting and composition, which are foundation of photography, right? So I want to highlight that lighting, composition are the foundation of photography. So I can select that structure, lighting and composition. I think you probably know what will show up. But in this particular case, I don't want images. I want text. I want a shape. So I can tell the system that, I don't need this image. I want an alternative representation. Just give me a shape and add text into it. So the text is added to the text box. And the next, I want to have, foundation of photography. So the visual effects can be one block supporting another block on top, right? So I can, click on the foundation of photography, then I have that block, and I can connect the previous lighting and composition with the foundation so that, I can sort of create a morphing effect. So the system has a little bit learning curve here, right? You like, it has this default effects, but you can imagine like, we can probably learn from all these online beautiful presentations to know what are the templates that one typically use for begin with for foundation, right? If the system has all the templates, you can flexibly combine them. But my point here is that, you are achieving your design goal, not by manually carrying out your design goal. You're doing this by telling the system, this is what I want to see. This is how I want them to be combined, right? So the AI is trying to interpret your, interaction and, do those tasks for you. So, I think these sort of are the projects we explored, right? And, I want to sort of show you guys what we have learned from these projects and how we apply it to other domains. I want to show you guys two other sort of interesting domains that, you may haven't thought of, natural language can be applied this way. How many of you listen to travel podcast? Raise your hand. Okay. Some of you listen to travel podcast. 20 million people in the United States listen to travel podcast every month. But if you think about it, it kind of doesn't make sense because travel is about seeing things, right? Listening is good, but you always want to be able to see things when you hear something really interesting in the conversation. So if travel is about seeing things, why don't these travel podcast creators create videos? Because create videos is hard, right? Like every travel podcast I listen to is like 1 hour long. And imagine you are creating a 1 hour long video. It's pretty time consuming. So if you haven't listened to travel podcasts before, here's an example for you.
The Tokyo of our sort of visual imagination, which is the blinking signs, the sort of like blinged out
giant intersections,
giant intersections, very busy kind of like sides of buildings, very tall buildings.
So if you have never been to Tokyo or haven't seen anything about Tokyo on TV or on YouTube, you probably don't know what they're describing. You can imagine, but you don't know for sure, right? So imagine it's describing on a very remote location you have never been to. You probably want to see it. So it would be nice to have some visuals for sure, but how can we help the podcast creators to create some videos, or maybe automatically generate videos even? So if you listen to the conversation of podcast, it's also very descriptive, because they are describing the location for you, right? They're describing the location, they're describing what's really interesting in that location, right? So we build a system that take the audio of the travel podcast as input, and then we do a speech recognition, convert that into text. And we build an algorithm, basically, you don't need to care about these equations. The goal is really try to understand at any moment in the podcast, what is the location that you're talking about? And what is the entity in that location you're talking about? Basically, extracts, rank all the locations appeared and select the top ones and combine them as a query and throw that into an image repository and get all the images and align that with the audio so that you have an audio visual experience. So this is the system. Like you will see the things grow and shrink. That's the ranking, real-time ranking of the locations and entities.
For example, Shinjuku is among the more famous. It's the one that people, well, there are multiple, but I think it's one of the ones that people think of most strongly when they imagine the Tokyo of our sort of visual imagination, which is the blinking signs, the sort of like blinged out
giant intersections,
giant intersections, very busy kind of like sides of buildings, very tall buildings. Shinjuku is tall for the most part. There are short parts of it, but Shinjuku is also the place where like Yakitori Alley exists, and that's sort of like on the other side of the train track.
So like if you look at this video, there's a last mile to go, right? Which is, the timing sometimes is a little bit off, right? The images can be better, right? But those are the things humans are really good at because, the timing actually a lot of times creates emotion, right? And the image you choose, indicates your own style, right? So, but you can take this generated video as a draft cut, right? And then add all your personalization into it so that you can create a really compelling travel video. So another domain I want to sort of show you guys is about sports. Who play tennis? Or who watched tennis games before? Okay, so when you watch tennis game, right, usually you have something like this. Sorry about that. So this is usually how, a sports game is broadcasted, right? But some of the, TV stations, they will add like commentaries, right? They will describe it for you. And that commentary is actually pretty exciting sometimes. It adds another layer of flavor into this. So let's see, this is a BBC commentary, I think.
Halep now reaching the low ball, scoops the backhand just inside the baseline. Williams cross-court. Halep down the line with a forehand. This is brilliant from Halep. Now running onto a backhand and cross-court for the winner.
So if you take the commentary, right, it's also text and it's also highly descriptive, right? Because it's really just describing the events on the court. And there are different types of description, right? There are actions are taking, and also there are things like, oh, this is brilliant, or, that's a winner, right? So what we did is we built a system and called Sporthesia, my postdoc built a system, and it automatically create a corresponding visual commentary. So let's take a look.
Halep now reaching the low ball, scoops the backhand just inside the baseline. Williams cross-court. Halep down the line with a forehand. This is brilliant from Halep. Now running onto a backhand and going cross-court for the winner.
This is pretty simple, right? But you can imagine an artist get in, create a really, cool and nice looking effects, right? And map it to, the commentary. And in real time, you are seeing these visual commentaries. But it's also very helpful for people who have just like hearing, problems, right? They may not be able to hear the visual audio commentary, but they can see all these visual effects. So, these are some of the things we explored in our lab. And, there are a few lessons we really, learned from these project. For one is you want to use smart interfaces and you want to use dumb AI. You want to use smart interfaces that understand people and dumb AI that you can understand. And I think that's the technique we have been applying so far that really make the AI integrated into your workflow. And the other lesson we learned is that the domains you pick is really important. If you want to apply natural language, right? You want to pick the domains where the knowledge and the user intentions can be easily indicated using natural language. Because not all the domains can be easily articulated. As Michael Polanyi said, we can know more than we can tell, right? A lot of our knowledge are test knowledge. We learn them by our experience, right? By playing the tennis. We don't learn dancing by reading a textbook. We don't learn cooking by, you need to follow the recipe, but you don't learn all the technique by just follow a script or, textbook. A lot of knowledge are tested knowledge that you gain from actual experience. But I think that's one thing that's really remarkable about AI is it actually can learn all of these tested knowledge, right? Like painting or self-driving, they are pretty tested, but they are learning it pretty good. But the problem is, I'm not saying AI, that's pretty good. The problem is humans really bad at articulating tested knowledge using natural language, right? So, we are good at, using our body or using our hand to, express our intention or test an intention or knowledge. Like, Maria Montessori said, for kids, we develop our intelligence by playing with the environment, using our hands and using our body. So in our lab, we have done a lot of work using natural language, but we have done a lot of work of using manipulation to express the user's design intention. So back to this Easter egg, right? So what are the things, we can do with manual operation, right? For example, like, let's say in the future, DALL-E gave me this Easter egg, beautifully designed, right? I may still want some, customization about it, right? Let's say I want to customize the color and I want to recolor these red petals in the top Easter egg. And you may say that, well, we just use a query, right? Change the color of the red petals in the top Easter egg. I'm telling you that doesn't work because, right, which red petals? There are different shades of red, right? And does the AI really know which one is the top Easter egg? From what I understand, DALL-E doesn't really understand it. Sometimes it's, got it wrong. But also to what kind of color, right? You haven't fully specified that. And specifying a color using natural language can be really tricky, right? Because you're trying to describe a very large space using natural language, and we don't have name for every single color. So I built this system called collection object that can try to help people design, customize the design. The problem we are trying to address with collection object is if you do throw this design into, let's say, a vector graphic tool, right? And let's say you want to edit all the petals on the top Easter egg. Manually selecting every single petal is also pretty tedious, right? So, if you imagine that workflow, at the one point you're like, oh, everything's great. I got this design. The next moment you have to, use the most difficult software. That's pretty bad. So what we did is we built a system that can sort of let you do these manual tasks more efficiently. Let's say you want to select all the petals with that color. You can sort of like tell the system that, hey, I want to look at the color, I want to borrow this color, and I want to use this color to select objects of the same color. Now you may notice that, hey, there are other shapes of the same color exist in the design, right? And I want to only select the shapes in the top Easter egg. So how do I do that? Well, I can tap the Easter egg, grab its shape, and use that as a filter together with the fill color as this query to select all the color, the shape of the color in the top Easter egg. And, I may get in, make the design, change the color a little bit. And if I'm interested in, editing other color, other shapes of the same color, I can flip this card, right? And then I can switch my, selection to another set of objects. So I'm combining a lot of these actions in this little sequence. So similarly, like, with this design, if I want to customize all the stars on the sky, I can say, hey, give me the geometry because I want to select all the star, right? And I can, select all the stars, right, with the same geometry, like everything is selected. But I'm lying to you, actually. That's not how you would work, because you don't really have this explicit intention when you're doing design. Like everything is pretty fluid, right? You don't have like, I'm gonna select all the stars or by this geometry. You probably just will get in and select the stars, right? So here, we also support that, if you don't have that intention initially, but as you are selecting, the system is looking at the similar, attributes and say, hey, do you want to select by the, star? And then, by geometry, then everything is selected. I think this is really subtle, but it's really important, right? Because if you're asking the user to always have an explicit intention, that's a lot to ask, actually. And also when you're doing design, every single moment you're making these decisions. So that's a lot to ask. Another system that we build is a system that can recognize what you write and into digital form. So here I'm drawing a table, right? Drawing is nice to define a table. And as I'm finished my drawing, I can say, this is a table. I want to recognize this as a digital table. I can recognize it. And when I recognize it as a table, I realize, okay, the last column is too wide. I want to split it. So I can just, perform a gesture to split it. But then the next thing I want to do is to merge the cells on top row, right? As a user, if I'm not very experienced, I may not know, okay, how do I actually merge it? What's the gesture, right? But then I start to think, if this is drawn on a physical board, I can actually erase the parts that I don't need, right? So here I can bring this table back and recognize it, right? Reverse the operation that AI did and, remove the points that I don't need and then re-recognize it, right? In this case, first to a stroke and then to the table. The point here is that when you're interacting with AI or these intelligent systems, you really want to be careful what the user is thinking of and give them the flexibility so that they can operate on the level they prefer. So back to this question, right? What would AI look like? And or will AI replace, graphical user interface or other things? I actually don't think it will, replace. And I think, in our research, we really just try to focus on little task automation. And a lot of things are good with AI, but they are pretty bad with AI, right? And for those things, you may want to use graphical user interface so that you can let the user get in, express their intention. But as I said initially, graphical user interface is also a packaged interface. It packaged the detailed logic that is described by programming, right? And for a lot of really creative design, you can't do that with graphical interface. You have to write program because the programmers haven't packaged it up for you, right? So I don't think programming will actually disappear as well. So, we need all these actually to work together. And in our lab, we actually work on all these levels. We build a system that can, sort of explore how AI can be integrated into your workflow. We build manual interaction techniques to support more efficient, expression of using gestures or using pen and touch or in virtual reality. We also build programming interfaces so that you can better articulate your intention when you're programming. So the final takeaway is really nothing is, the best for everything, right? Everything is good for something and bad for something else. And the best thing we can do is really just to combine them in a really nice way so that the user can directly and flexibly express their intent and to enjoy the collaboration with AI without getting into the problems and to unleash their creativity. So that's my talk. Thank you.